requests, and I decided we had to go to a Saturday call. And so, but that first Saturday call was amazing because I asked everyone, look, you're going to ask a question and be brave to ask it in front of everyone because only nice people are coming. But I want everyone else to help that person with their question too. And a very brave young woman was the first one to ask the first question, Navina, and you could see the blessings flow through her face as we kept trying to help with her question. And it's only gotten better since that very first meeting. More and more people joined us that had a more together spirit, which means if I know more than you, I want to help you know as much as me. And then if we're growing in knowledge and skills together, we can help each other go higher together than we could have by ourselves. And so I want to make it absolutely clear to everyone that showed up here today too. We run the most expensive mentoring program on the planet. No, you don't pay us any money. It's more expensive than that. You're making a commitment to take what you learn from us and pay it forward. Help the other people that know just even a little bit less than you. Any way you can help them at all, you're trying to help them in hopes too that you can grow together, like I explained. So we will kind of revisit some of these blog posts today, but I want to start with this very basic workbook. And then we're going to go to a workbook that's not advanced, but a little more challenging, but it'll be good stuff for you, I promise. And the link for this is public. I'm going to share this in the chat. Please, I think everyone can get to it. You can view it and make copies of the notebooks here, but I'm going to put that in our chat right now. Let me find our chat. So if y'all will open your chat, you'll see the link right now, and let Hugo know if you, and you can just message everyone when you say it, but let Hugo know in the chat whether or not you can see it. Now I'm going to close my Google Meet link, Hugo, and you said you have it open now, so I'm going to just close it, and that'll help my system too. Okay, we're done here. Now we're going to go to this very basic notebook, and now we are officially getting started. Sorry for the hiccups, but we still have plenty of time. So you're welcome, Irene. When we are starting a notebook for machine learning, this is one of the things we're probably always going to import. Matplotlib.pyplot. And we're making an alias for that whole module called PLT. And understand something, you don't have to do it exactly this way, but the community is pretty good, you bet, Gene, showing things in the same way. Not always, but this is kind of like data science speak, machine learning speak among the data science community. So if you do this, it's like you're speaking our lingo, but obviously Python's so flexible you can import differently, but I'm going to go ahead and import that. And Ivy's saying good morning to everyone. She's yawning. Ivy's a golden retriever puppy, but looks big now. Now, we're starting super simple here. And by the way, I love when I'm helping people to start with super simple examples, because I would want to do that. And when I'm teaching myself now, I test the principles I'm learning with really silly, simple examples. So I'm going to create a feature set with 2 data points, okay? And we call these features, but another thing we could call them is inputs. Someone's not on mute that probably could be. It will help everyone if you'll be on mute, unless you have a question. Okay. Okay, someone, if everyone would check if they're on mute or not, that would help. Now, also labels, even though we call them labels, they're truly outputs. Still learning to type. Okay, so I'm going to load this tiny, silly, simple features data set that's got features and labels, inputs and outputs. you go, I think you have the ability to mute everyone but me, but see if that's true or not. Okay, now.
Yes, I'll do that right away.
Very good. Because some people just don't realize they're not on mute. It's not intentional, I'm sure. Now let's visualize this silly, simple data set. Oh my, have you ever seen anything more simple? I've got my X points here, which are 1 and 2, and I've got my Y points, which are 2 and 4. Now I'm showing you, I'm trying to prove to you right now, no worries, Mitch, no worries. We all help each other. When you learn to do the equation of a line and fit a line between 2 points, you were learning the most basic form of machine learning. Okay. And well, what does that look like? It looks like y equals some coefficient times x plus b. And b would be the y-intercept, c would be the slope. Well, it's maybe been a while, you might have forgotten, but how do you calculate c? Well, you take y2 minus y1 over x2 minus x1. And you're literally looking at how much does y change with respect to each change in x. And then we just do a little bit of algebra here. Once we know that coefficient, we can figure out the y-intercept by this little bit of algebra here. So I've done that right here at point 2. If I take away the coefficient times that first x that corresponds to the y at 2, I can calculate my b. So let's look at those calculations, and that looks reasonable. Okay, and now what are we going to do? We're going to just visualize how well our model did, but we're going to put some new x points in the middle of it to use this model to predict, well, what y values would occur between 1 and 2. So I'm going to run this block. Now, in case anyone is feeling insulted, please don't. I can't tell you how many times I've gained insights by just thinking about this again. Stay with me mentally here. If you feel like, oh, this is just painfully simple, trust me, it will probably have some value here. Now I want to visualize what we just did. Isn't that cool? For this simple example, now I'm able to predict millions of points that would have occurred between 1 and 2. And with some care, because I don't know that I trust this model for all data points moving forward, I might be able to extrapolate. So far, we've interpolated. We've gone between the range of our data points. But sometimes we could go either side to the data we collected and predict, but you don't want to go very far if you do that, because you don't know that this model won't change a lot as we go way beyond the range. Now, a bit more real machine learning problem. Well, it's not that I should change this, and this will be fun because you can see me doing a little markdown. This is one of the simplest markdown tricks. Put a hash sign in front of this in your Google Colab notebook, or really any notebook, and you can change the title. But let's say not a bit more. This first example was no less real. How about a bit harder? Oh, still learning to type. Machine learning problem. Okay. So now look, I'm going to import NumPy. And again, this is the way we speak to one another. Import NumPy and create a shorthand notation for it called NP, or an alias, we call this. And then I'm going to create a new feature set for X called I'm going to sample points from a random uniform distribution. I want values from 1 to 51, and I want 100 of them. And then this is a little trick in NumPy. Don't let it confuse you. -1 means the original dimension you had by 1. So what this is going to do, just this much would have created a row vector. But we want to make it look like a column vector, meaning a matrix with one column. So we're going to look at that so you know what I'm talking about. And boom. And I really could have done this. I want to see that first column. Watch, it'll do the same thing. Oh, no, because it turned it into a single array because, well, you just wanted to look at that much. But if I'm saying, look at all the rows of this feature I just created, oh, you've got a matrix, but it's just got one column. So be aware of that. When you do look at it at that level, it's just going to change the dimensions on you if you were to reassign that. Like say, x test equals this x colon 5 comma 0. Now it's going to turn it into a one-dimensional array again instead of a two-dimensional array with one column. But you will eventually run across what I'm saying. It matters in machine learning, the format of the data is all I'm saying. So now we want to create some fake labels, in other words, some fake outputs. Okay, you go, there's a comment for you there from Latifat. Create fake labels with a model that we pretend we do not know. Okay, so what I'm saying is we're going to create these Y labels. And here, how are we going to do it? We're using a model. We're using the equation of a line. We're going to say 2 times X plus 3. So 3 is our Y-intercept, or our bias, you might hear it called. 2 is our coefficient. X is our features. Now, oh, and guys, since you can get to the notebook later, please don't open it while I'm going through this. I'm just talking pedagogically. I want you to watch what I'm doing instead of looking at a copy of the notebook. But I'm not telling you what to do. I'm asking you to do that. Okay, so now I want to create a noise fraction because I want the data to look kind of realistic. Well, I'm going to call it 5% or 1/20th of the max noise. So I get the max of Y here from using NumPy because this is now a NumPy array. Oh, and notice that I originally started out, I really didn't need to do, when this is already a NumPy array, I realized I did something I didn't need to do. So when I say np.array Y, I was thinking I was turning Y into a NumPy array, but literally, I don't need to do that. I want y'all to appreciate what happened here. With NumPy, it created a whole array of Y from that 1x. That's the power of NumPy. You can, if we were doing it in pure Python, I'd have had to do all the separate points of X to get all the separate points of Y in a for loop. But this, rather than discuss it, let me illustrate it. Now remember, X is an array, a NumPy array. Look what it did right here. It went on ahead and created a whole array with all those points. And then it was showing this second array here. Let me squelch this one. It was just showing the top 5. So just to show you, yeah, isn't that amazing? Now, to make sure what I'm telling you is correct, let's just say this real quick. We're going to make sure we reshape Y. I'll keep this in here so y'all can reuse it for your own edification. And boom, no problems. We should have printed that after all the noise was added. And boom. Now we're going to look at it even more here in a minute. But let me go back to this now. It's getting the max of those outputs, and it's multiplying every one of them by noise frac. Excuse me. This is, by noise frac. But then it's saying, wait a minute, let's see, hang on. Yes, this is just creating the max noise that we will encounter. It's just one value is what I'm saying. But now I want to go from negative Y noise to positive Y noise, and I'm going to create 100 points. How? I'm sampling them. So if we were to print this noise, just this part by itself, it would just be values between negative Y noise and positive Y noise. And I encourage you to do that on your own time. But now, if we print this, we would see different values at this point than we saw up here at this point. Okay, and you can see the results right here. I'll rerun that. Oh, if you don't like to see this gobbledygook right here, a little trick, just add a semicolon there and it magically goes away. So now you can see, oh, I had my original points that were in a straight line, but I've added some noise so it looks more realistic. And so what's happening here, when x equals 10, well, y would have equaled 20, but now there's been some noise added. Okay. Now again, this y profit, we're calling that because we have this special knowledge. We know what the perfect model is. And so that's why I'm calling it y profit. And then I'm going to do a scatter plot of it. Again, this is matplotlib.pyplot.scatter, but I created a shorthand for it, so I don't have to type that all the time. Oh, excuse me. Just like we do in P dot stuff instead of numpy dot stuff. So plot.scatter xy, plot, and now I'm going to say what x times y profit. And you see that line is right through the middle pretty much of all this fake noisy data. And then we just show it. Well, that's all fine in profit mode, but what if this is real world data. Someone gave me the y data, but no one's told me what the perfect model is. If someone could always tell us what the perfect model was, we wouldn't need machine learning principles, right? So now we're not prophets, but we are analytical people. So we're going to use some analytical tools created by people much more skilled and experienced than us that put all their tools in a module called scikit-learn, or sklearn for short. And among the many modules they've created for us, they've created the linear module. And inside the linear module is a class called linear regression. Now, don't get hung up. A module in Python is just a file full of classes and functions that's been saved, and we have access to it now. And how do we get to it? Well, from this module, we're going to import this class. Just that simple. And then what I'm going to do, because classes can be used over and over and over again, we don't make copies of them, we make instances of them. And then we can change the specific parameters or attributes of those classes, as we call them. And so I want a copy of X. Oh, great, good to know. For someone just left me a comment. Let me read the whole comment. Yes, understood. Now, I'm going to do what's called a fit. Well, what does that mean? Well, you remember up above when we calculated for the slope and the intercept? Well, that's what we're doing, but this is a much more involved process, because literally what we're trying to do during this fit method that belongs to this linear regression class, and we're using it for this specific instance of this class, we're saying that this linear regression class has a method in it called fit that figures out the best parameters so that when we pass that model, it's fitting through these data points, it creates the least amount of error between the predictions and the actual data points. And by reasoning, by inference, we would think, oh, that must mean it passes perfectly the best balance between the data points, and that's right. So after we fit it, we're going to look at the coefficients, and because we have special knowledge about the model that created this data, we'll kind of know how well it did, and then we'll even create some predictive points that we can view down here. Excuse me. Well, the model bias, the intercept is 4, and the model coefficient is almost 2. Well, let's go back to our profit mode. Oh, we're a little off here on the intercept, but not bad. But it's compensated by making the slope a little less. Well, why didn't it get perfect? Because noise is not perfect. Now, I'm going to show you something really, sorry for my coughing, just something, I do this in the mornings. Trust me, I'm okay. Well, let's go down and see. Well, we'll just keep running with this because, again, this isn't perfect, but with our special fake data knowledge, we know that, oh, perfect would have been 2 and 3. And without any noise, we absolutely would have gotten those same parameters. Run that as a test yourself. Do a version of this, making that noise fraction 0 instead of 0.5. But now that we look at it, we realize, hey, wait, for the noise that we had, that is the best model because it reduces the error the most. But as we collect more data, we probably see that this gets closer and closer to 2, and this gets closer and closer to 3. So far, we have our own little pipeline here, we call it. It's the way we go about the machine learning process. So now, just to prove my little point above, we're going to create a method, or excuse me, a function based on the number of points. And we're going to create a new feature and new Y values, and we're going to reshape them. Everything we did above, I'm just repeating everything we did above in one block. And I'm going to look at the coefficients, and then I'm going to return the intercept and the coefficient for each number of points. Now I'm going to put this function in a loop right here, model with num points. And I'm going to go from 100, what we just did, to 100,001, and I'm going to take steps of 100. I just want to show you the point I was making above. So we run this. Give me 1 second. Okay, I'm back. So those of you that have known me longer, you know my wife's name is Sue. Sue and I are roughly the same age. And we were out to dinner one night and we were coughing. And I looked at her and said, you know what? We have old people throats now. And we both laughed because we remembered the way our parents coughed as they got our age. And so it almost sounds like we're people from a nursing home sometimes. Okay. Now I'm going to do a plot of these X points and intercepts. And look at that. As I increase the number of points, what are my intercept values converging to? They're getting closer and closer to always being 3. Well, what about the weights or the coefficients? Look at that. Yeah, they may vary a little bit. And look at the scales here. These are pretty good. That 4 was actually quite large. If we reran it with new randomized data, it'd be smaller, but see how we're converging on 2. But because of the noise and the randomness of the noise, it's never quite exactly 2. It's never quite exactly 2 for the coefficient and 3 for the y-intercept. Now, just so that we can see this a little differently, I like to sometimes put things on a log scale. And so this is a little more linear, in other words. It's just another view. I just took the log values of all those points. Okay, now, well, I hope that, and let me catch up on the comments here. Okay, now, I'm going to take you through a different notebook. Ooh. Hello, Linux, wake up. Okay. Why is it? That's disconcerting. Let me try something, guys. I don't know why it's being that way. There we go. I don't know why it was doing that. I'll leave a little border here. Okay. Well, what we just did there a minute ago was only linear regression. But look over here in my table of contents for this second notebook. I'm going to do some fake feature creation again, fake label creation. I'm going to notice that we were training and visualizing on all the data. Well, we'd like to do what we call a train test split. We use most of the data for training, but we save some of the data to test with. In other words, we'll fit the model that we get a model that reduces the error as much as possible for that particular map, that particular algorithm that's figuring out how to make predictions. And then we test it on some other data. But with that other data, we still have the labels, we still have the outputs, but we're pretending we don't have them. And then we're seeing how good the model does. We'll introduce some model metrics, and then we'll try a bunch of different algorithms in this. And this is going to look like, if you guys have ever seen the movie The Titans, it's a famous high school football movie from my culture. And Denzel Washington, a famous actor, plays this black coach in the South when it was still hard to be black in my country. Forgive my country for that. In fact, I grew up in quite a prejudiced area myself, and thank God he got, well, I have African kids now, so I'm clearly not prejudiced at all, but I struggled with it in my youth because of modeling around me. But in that movie, it's incredible because he's a very good football coach, and he talks about the wisdom of having a simple playbook. In scikit-learn, even though it's programmed by incredibly brilliant coders and data scientists, they've made it so it's like Novocaine. You take it and it makes everything feel better. In other words, you're going to see very repetitive patterns as we go through this. For each type of modeling class, for each type of algorithm, there's always a fit and a predict. And so they use the same method names in all these different classes for linear regression, decision tree, but the hyperparameters will be different. If you're not familiar with hyperparameters, you will be soon, because they're different algorithms. But I'll let y'all read this on your own. This is very good stuff. And in the second and third session, we're going to go through more details about the process. But let's create more fake features now. Let's get a little more complicated. Look at what we're doing. So that I don't have to scale, I'm making 1,000 points between 0 and 1 for this data set. And then I'm horizontally stacking them together. Just taking a little longer here. Now I want to create my fake labels. And notice I've created my random noise. I just want y'all to see that I created random, normally distributed noise. So it's going to change a little from that histogram we were just looking at. This is pretty much normally distributed. And notice that, yep, it went from 0 to 4 because of the care I took to do that the way I did this. Sorry, we don't have time to review the statistics here on why this worked, but if you look at it long enough, you go, oh, yes, of course, that makes sense. Now, like I was promising, we're going to split the data set in a train and test groups. So here's from scikit-learn, what to do if noise isn't normal. Oh, I forced the noise to be normally distributed. And noise usually is normally distributed. But if it's not normally distributed, you just deal with it. And we can talk about that in another session, but it's not that big a deal. It's just another thing you might have to learn some tools for. Well, here's that from this new module in scikit-learn that I've aliased as scikit-learn model selection, or SKLMS. I do a train test split. What that's going to do is I'm saying, here's my X, here's my Y. I want my test size to be that fraction. I'm going to use the same random state, so this gets changed every time. And yeah, go ahead and shuffle it for me. That means it shuffles it compared to what I originally gave it. And look at this. It creates the X train data, the X test data. And again, this will be 20% of the total original data set. This one will be, and this will be 80%. This will be 80% of the outputs and 20% of the outputs. And when I run that, yep, sure enough, just like I promised. Okay, now we're going to create some model metrics. Yeah, Hugo, don't worry too much about that because we can take questions. I can stay longer because class was canceled today. And old man throat. We can handle questions over the Slack chat too. Anyone that showed up today that's not part of our integrated family, again, it's very expensive to join our family. You make a commitment to help everyone. Okay, so, but it's no money. And by the way, the best way to grow is to help other people. I can vouch for that. But join our channel, join our Slack work group. Hugo will tell you how to do that, and then we can help you in Hugo, we already have a chat for this called Tech Time Chat. Okay, so what do we have here? We have mean squared error. We have root mean squared error, mean squared error, yeah. And it should be root, but then mean squared error. Oh yeah, this is just a way to take that mean squared error and make it the root mean squared error by the square root. We have mean absolute error. And by the way, you're a Google search away from understanding the detailed math for these. But we will be having a session on that in the future. Let me let Caleb out, the big dog that many of you know. Okay. And then we have the R squared score. And that's a way to judge the goodness of a model. The closer to 1 it gets, the better. Or if it's 1, it's perfect. And then there's an adjusted one, which penalizes the score based on the number of parameters in the model. In other words, it's pushing you to have as few parameters as possible. Yeah, Gus can help y'all too. Thanks, Gus. Okay, so now we're going to go through each of these models with each of, and look at all these metrics for each of those models on the data set we created. So here's linear regression again. And notice, now I can't always use this, but for this module, I can use the score. See, I've done linear regression again, but I've called it mod LR. And I fit it with the train data, and then I'm scoring the train data, and I'm looking at the coefficient. Now, let's double check. I'm drawing a blank. Let's look at our model. Oh, my bad. This score is like an R squared score. But if you remember, we had, we had coefficients of 1, 2, 3, and 4. And so what this is saying is on the training data, you rocked, or not me, but the linear regression model from the awesome scikit-learn team. Well, now let's do a prediction with X test. And then we'll run some metrics. Uh-oh. That's because Dad stupidly forgot to run this cell. There we go. Well, look at this. Very small mean squared error. Root mean squared error is pretty small. You get used to what these values should be. Then the R squared error, and the adjusted is always going to be at least a little smaller, even for simple models. But this is telling us you rocked. Now, an exercise for y'all to add to your own copy of this notebook. Visualize a line plot of Y prediction against Y test, and you'll see it pass through the data points. with minimal error. Now, a whole other branch of modeling is decision trees and random forests and stuff like that. So notice we can do the fit, but we do have a score feature here. So we're going to rerun that. We're going to get a new predictor, a new model, and oh my, well, look at that. It did perfect on the trained data, but watch this. It didn't generalize so great, did it? Look at that. That's 0.91. That, shoot, what's that telling us? It's saying, yeah, it trained perfectly on the trained data, but when new data came in, it wasn't so hot. Well, is there a way for us to fix that? Yes, with a random forest. So this is a decision tree. This is a forest of simple decision trees. And it comes from the ensemble group. So when you hear ensemble modeling, the most basic form of ensemble models are random forests. So we're training. Now, oh, it wasn't perfect like the decision tree, but look at this. It generalized better. Well, boy, that's cool. Could you, now notice it didn't do quite as good as linear regression yet. That's just because of the nature of what we're doing. But sometimes random forests are absolutely one of the best models you can use. And don't think you'll develop a skill to know absolutely what model's the best for which data set. No one does. That's why we run through all these models. But you can see brilliant friends like those from Scikit-learn wanted to help the community and they created these tools. So AdaBoost, okay. Let's look at AdaBoost. Oh, it didn't do that hot on the training data. Now, what AdaBoost is known to be good at is generalizing, being pretty good on generalizing, meaning as new data comes in, it's just set up so it does good on the new data relative to a lot of other methods. But let's look at how it does on the test data. Ooh, okay. This is looking almost as bad as decision trees, but now let's play with some hyperparameters, okay? Let me take away the evidence. Okay, so I did a previous experiment cycling through different hyperparameters for the N estimators parameter of AdaBoost. And this is the regressor, meaning the continuous problem version. There's a different version for classification, and forgive me, I should have pointed out, we're only doing regression on this track, but we could do very similar things with different metrics for classification problems. And we can have a fourth session if we want to do that. One second. Well, let's run through these and see, can we get better? So look at what we're doing. We're doing a score on the training data for each of them. So you can see I went to 100, I'm already better. And as I keep going down, I do get better as I go to a higher number of estimators, but AdaBoost is just not doing that great on this data set. So that's okay. Let's go try another ensemble method. By the way, this is not part of the Scikit-learn data modules. However, you can, the XGBoost site, oh, let me fix this. This is hard to look at. I will make this easier to look at for you guys. Markdown is a great skill to have. The XGBoost site, I just find it kind of confusing for machine learning stuff. So I gave you this Geeks for Geeks example. They show you how to use it and how to download it. It's great. Okay, now I'm going to import XGBoost as XG, and I'm going to run the regressor. And whoa. Can you get a negative R2 score? Yeah, we just did. Some people ask that. Can you get it? You'll see it in the online questions. And Oh man, this is horrible. It did even worse on the test set. But let's run through different hyperparameters again for the estimator. I'm leaving the depth at 3 here. Oh, that's better. Oh, wow. This is a really good model. Look at this. And it keeps getting better as I go up in estimators. And I could have gone higher, but we could have played with this hyperparameter too, the depth. So XGBoost is a good friend. There are many times I find it does better than any of the other algorithms. So you definitely want to keep it in your pocket. Now, Bayesian, it uses, yes, Bayesian principles. We're going to try that one now, and it's part of the scikit-learn linear module. And ooh, wow, that does really good too. So that's one to keep in mind. If you would really want to get in deep on the math of any of these, you're a Google search away. There's a wonderful professor at MIT that does a great lecture on support vector machines. And it's like, you know, our history, some of our history for machine learning, the people that created this stuff are still alive. You could go meet them and thank them. But support vector machines, they're amazing. We've got regressors for them, and we've got classification routines for support vector machines. But this is a support vector regressor, SVR. And yep, it does great on this data set. Isn't that superb? Now, you've probably heard, and I've emphasized it, if you're using deep neural networks, you have to have a lot of data. But what if you don't have a lot of data? We'll just use a smaller neural network, see if how well it does. Okay, that's doing good. And something I feel, once you get the right architecture, neural networks can generalize very well. But again, I want you to look at this. They're using the old language, multi-level perceptron. That's what that MLP stands for. That's the original language of neural networks. And notice I'm only using one hidden layer of 2. If we played with different numbers of hidden layers and different numbers of neurons in each hidden layer, we could really affect the results. So the hyperparameter work in neural networks is harder because we're actually controlling the number of parameters. Now, cross-fold validation. This is something you're going to want to play with more. But now I'm just looking at changing what group of the data set is the test data. And why do I do this? Well, for the, I'm looking at mod LR, mod BR, and mod SV. So that's the linear regressor, the Bayesian regressor, and the support vector machine regressor. And all I'm doing is looking, I'm using this cross-validate class in model selection to say, okay, from this model list, send in the model. It's cool. It's just amazing. And here's all my data. And I'm making sure Y is a column vector. And then I have 5 folds. And I want to see the R2 score for each of them. And then I'm looking at the train scores and the test scores. And I've already run this. So you can see, let's see. Yes, it's looking at the 5 folds for, this is the train and this is the test. And now we can compare all of these on crossfold, and they're all generalizing well, but you could use this to pick your favorite. Now, again, this is fake data. It worked really well, but you know, on real world data, it might not go, you know, turn out this high. Okay, I want to take questions now.
Okay, so before the questions start rolling in, if you want to, I will just allow anyone be able to unmute themselves right now. And then if you don't want to be able to, if you don't want to speak into the mic, you want to ask through chat, we're also monitoring the chat window. All right, so I'm aware there are a lot of people who came here and they have not been into the world of data science before, and they are just trying to make their move. Okay, so what Thom has just said is he just tried to show you what a normal day in the life of a machine learning engineer is. And it will help you know what you want to get into when you decide you want to finally, settle into machine learning. So this what he just did here is like machine learning end to end, So it just shows you the day-to-day life of anybody who is a machine learning practitioner, and then you can now decide for yourself: is this what I want to do every day when I come to work? Does it sound interesting enough?
Now,
Do I?
and
Yeah.
and and Hugo, I should have pointed out, we started with very clean data that was fake, that didn't need to be scaled, that didn't need to be encoded, that didn't need to be cleaned, that we didn't need to do any feature engineering on. We
Right.
started at the end, and then the next sections, we're going to do the harder work of, okay, what if the data's got these problems or these problems? But yeah, what you're saying is perfect. This was meant to be a high level overview of the model selection process, what it means to do predictive modeling, the different models we can use for machine learning. And if this was overwhelming to you, it's okay. Just go back through it. Listen to the recording again. It will make more and more sense over time.
Okay. So
And
I
then
have. Oh, go ahead, Dad.
as you work through these workbooks on your own, or you try to do them from scratch with looking at guidance from these two, we'll help you get on the Tech Time chat. And really, I want the other family members to try to help you. What they'll do is bring the harder questions to me. Go on ahead, you go. You're doing great.
Okay, Dad. So I have a question sent to me directly, and the question is going to be anonymous because I'm thinking the person sent it to me directly because they wanted it to be
Sure.
anonymous. So it reads, "This is very new to me and it's overwhelming. So
Yeah.
where do I start from if I am new to data science?"
Reason I started on this notebook up here. Now, it's fine. Still chat privately with Hugo. Did you understand this equation of a line thing? And then
Okay.
ask yourself, and did you understand getting the y-intercept and the slope? Now, we didn't go through the detailed math, but if you want to go through the detailed math, and it'll take you time to go through these old blog posts, but on the integrated mlai.com blog, I have all these old blog posts. They show you how to do invert a matrix, which is something you would need to do to solve for this stuff with ordinary least squares. And then skip this one. This is more advanced. But then I show how to solve a system of equations, which you would do with ordinary least squares. But it's related to ordinary least squares. We haven't gotten there yet. And then I show how to create your own set of linear algebra tools so you understand that. Then how to find the determinant of a matrix. This is all stuff important to the detailed math. In other words, it's saying, oh, start with the equation of a line. Once you understand that, how do I fit the best line through a bunch of noisy data points that seem to show a continuous pattern where I can come up with a predictive model? If you want to get into the detailed math, this is how you do it. So finally, we get to how to do a ordinary least square solution for that noisy data. And then we create a class from it like scikit-learn would do, but mine's not as sophisticated as theirs. And then this is, don't worry about that one yet. But then we do this least squares with polynomial features. This is feature engineering, basically. I know I may be overwhelming you, but just get used to the lingo right now. Then clustering, and then, boy, I wish they had a navigator up at the top. And then finally, we get to how to do gradient descent. And that's another tool you may need when you add more complicated things to a model. But the only reason I was saying that is when you start here, just remember the equation of a line and understand that the tools get a little more complicated when the data, well, a lot more complicated when the data looks like this. Because why? The data is complicated now. It's noisy. I want y'all to understand, all we were doing was finding the best model that would say, given an X, what's the Y? That's all we're doing. Given an X, what's the Y we should predict? But it's doing over and over and over again. And it's okay to initially learn just how to use these different models to predict. I've got some data. I've trained my model on my training data here, right here. I've fit it on my training data right here. And now I can do predictions. So I take this data that I've held back to use it to make predictions. Now, if you're brand new to this, yes, any lecture where someone's trying to help you get started, it's going to feel overwhelming at first. Stick with it. Start with really simple examples. Expect it to take a long time. And let me encourage you, the people that originated all this, it took not years, not even decades, it took centuries to get to where we are now. If it takes you a year to get comfortable with this, that's exceptional. And you can do it in less than a year, I think, but don't expect it to be a cakewalk either. Don't expect it to be super easy. It won't be, but it is super rewarding. It's super powerful.
Okay, I have another question here.
Yes.
Can you do data science without machine learning?
There's a lot of data science with statistics and like hypothesis testing. Some of the big companies don't do necessarily a lot of machine learning. They'll maybe do a lot of data storytelling with statistics. They'll do hypothesis testing. They'll do experimentation platforms to optimize the number of sales they're making on a website, or at least the number of views they're getting. This is one of the common areas. It's one of the rites of passage to learn to become a data scientist or a machine learning engineer or even a business analyst. Now, I want to encourage everyone, if you just want to get a good data job, but you think I can't expect to get into this very soon, learn from my son, Hugo. He is helping the family immensely with learning Power BI. That is a Microsoft tool that's a lot like Tableau and Google Data Studio, but it's superb. I learned it myself a while back. It is a phenomenal tool to learn to tell stories with data. And I try to teach everyone, by the way, again, we use really well-structured data. Normally, we don't get the data that way. The next 2 sessions are going to be about how to clean data, how to scale it, how to encode it, how to do feature reduction, how to do feature engineering. And we're going to do very simple examples. I made this as simple as I could to give you a fast intro to machine learning. But if it overwhelmed you or you weren't sure, don't let that scare you away. Take your time with it. But also, if you want to get good fast, follow my son Hugo to learn about data storytelling and data business analytics. It's basically the way to take data and start sharing insights from it with others. We can stay after the hour for anyone that wants to, because we had to cancel our class today because Guy is sick.
Okay, I think I have another question here. Let me take the one from China first, since it's open to everyone. Then I'll take some more anonymous questions. Okay, so how do we choose which ML model to use for given a given set of data that we are working on? Are there any key points to consider before you choose the model?
Yes. So, and I'm sorry if this was lost in the speed we went through this. Notice that we tried all these models, and for each one, we collected metrics for those models, right? And so every time we collected metrics, but then we used this initial process to figure out which models were most promising for our data set. But then down here in Crossfold, what we're doing is we're seeing which one had, we're kind of looking at to see, okay, what is the average of this, these test results? So again, this is R squared. That's a good model metric, how well the model's performing. What I look for, so again, above, over here, looking through all these, I decided which models I wanted to include in this test down here. Once I've got the results for each of those models in a cross-fold validation, again, that's where we take a piece, each piece of the data gets a chance to be the test set. And when I have a high average and a very low standard deviation, I know that's my best model for where the data set is currently, okay? And so basically, I'm just looking at, boy, these two did exactly the same. Is that surprising? No, not between Bayesian and linear regression, I guess not. But this one was a little different. So it would be between these two in this case. I wonder, let's see, I'm having a doubt. I wonder if I did something strange up here. MBR, no, they just, for some reason, boy, I really want to investigate them. But anyway, I diverge. So you don't know ahead of time which model is going to work best. But when you see really good average metrics and they don't vary much from fold to fold, that's telling that model is going to work good on new data, or it's going to work. We have a higher confidence that it's going to work good on new data compared to the other ones. I hope that makes sense, meaning we call this generalization. The model's generalizing well across all the folds. It gives us higher confidence that it's going to do well in the future. Now we're going to create uglier and uglier data over time. So you'll see that, oh, okay, that's a challenge.
Okay, let's take,
now,
okay, go ahead, Dad.
Well, just real quick, regarding lasso. Lasso is a technique applied to linear regression, super powerful. We will be talking about that in another session, but Sharman, if you can ask that question in Tech Time chat, we'll tackle it there. It's a little more advanced than we want to go for this first session.
Okay, and to respond to Doug, you said we have referenced the next two classes here. So it's technically not the same session. We're not repeating this next week and next 2 weeks. They're like advancements, to build on each other. All right. So I think that's it's no repetition. You would also benefit a lot if you stay for the next session next Saturday and next 2 Saturdays. Right. That a question for someone who's just starting out in data science, what would be the right trajectory in terms of what to learn first and then what to learn next?
So I typically give this same advice all the time, but let me give really high level advice here. Right here, your personal data science learning plan. It's really important that you attempt to make your own learning plan. Now, I should say that you maintain your own learning plan. I promise you, even if you take an example of the starter plan that I only use as an example in this blog post, your first plan is going to suck. It's going to stink. That's okay. Start with it. But as you learn more, you will refine it and refine it. And the smartest people don't just make plans. They revise their plans frequently as they keep learning, but do maintain a plan. It will help you so much. And because you can be tempted to run off and learn the latest, greatest thing when you haven't mastered the basics. Master the basics. And so, what do I mean by that? Get really good at using linear regression, and its cousin in the classification realm is logistic regression. If you master those two things and understand how to apply lasso and ridge to them, you understand gradient descent, you understand how to use them to figure out feature importance, how to get rid of multi-collinearity or just collinearity. If you know how to use them both to get to reduce the number of features you have or to increase the number of features you have with all those things, get really good at those two. And then with decision trees and random forest too, but take your time. Even that's going to take a while to really understand them in depth. Why do we start this way? Because you can do this right away. If you can get your data and split it into train and test, like we did up here. Notice we use the same data over and over. If you can just collect some data, and we'll go over scaling too, because that's going to be important. We'll go over encoding, because that'll be important. We'll go over cleaning data, because that'll be important. But once you have that clean data, if you can run this code, you can do, and you can use these metrics, you can do machine learning. You don't have to understand how each of these algorithms to work to get benefit from it. The notebooks we're going to create, you can start to do Kaggle competitions and work for a company. You can start to do that right away before you understand the depths of all these algorithms. But over time, as you're improving your learning with your own learning plan, you'll realize, oh, okay, as I'm building up my basic knowledge, I want to understand this aspect about linear and logistic regression in this aspect, in this aspect. Then you can go deeper into neural networks and into support vector machines. But you don't have to know it all right away to start getting value from it immediately.
Okay, that another question. Data science seems like it involves a lot of statistics. Would this be correct? Okay.
Okay, now in the machine learning, you could get by without knowing one stitch of statistics. Let me show you something. But by the way, I am not saying you shouldn't master statistics. Please, nobody take that statement that way. But I want to show you something. Down here, for me to get a feel, I don't have to be an expert at even calculating mean and standard deviation to see that, whoa, that's a high, that is a high average with low variations. What did I just say? It's got good mean and good standard and low standard deviation. So does this one. This one's not quite as good down here, but it's still good. Again, it's because we're using very clean fake data. This is very simple data. But a lot of machine learning engineers, they could get away their whole career. That's assuming things don't change without knowing statistics. Now let's say, oh, I want to become a lead data scientist at Google. Oh, you better know statistics like the back of your hand. You better know SQL like the back of your hand. But for a lot of positions that you might be able to find, no, you could get by without knowing statistics too well. You really want to understand the depths of machine learning and data science. You want to keep getting better your whole life at statistics. But also, you'd like to keep, as you grow in what you're learning, in your detailed learning plan, you're going to add calculus. And you don't have to learn all of calculus. You don't even have to understand it at a deep conceptual level. Just appreciate it at a conceptual level. And there's pieces of calculus that are very important to aspects of machine learning, like in neural networks. Um, I absolutely use calculus when I'm deriving how to do ordinary least squares solutions. I also use linear algebra. So you want to know statistics, you want to know linear algebra, because a lot of what is going on is linear algebra. You want to know um, so statistics, some calculus, a good amount of linear algebra, but then I'm not sure I completed answering an earlier question. Get really good at Python. But here's an example. Learn Python and statistics together. Learn Python and calculus together. Learn Python and linear algebra together. And well, how could I do that? Start practicing. If you went through this and you were really working hard and had many references open, you could be learning Python and linear algebra together. You could be learning Python and solving a system of equations together. You could be learning Python and creating your own linear algebra tool set. In other words, this is my NumPy replacement. I'm not going to use this instead of NumPy. I created it so I would understand the bowels of NumPy better. I already knew linear algebra when I created this post, by the way, but I wanted to grow in my appreciation of how it would be coded. Because when you can code some math, you really understand the math. There was a point where I realized, hey, I need to calculate the determinant of a huge matrix. Um, Here, I'm using least squares to solve for a system of equations. Um, it, it, that's when you have noisy data like we're seeing. Take some area of math you want to learn and learn Python together with learning that math. You'll be glad you did that. But again, this is like a long hike that's going to take you months and years. Enjoy the hiking, enjoy the learning. It's beautiful, but take a break, watch a movie, go out with friends. Don't kill yourself learning this stuff. This isn't your whole life, but always try to gain greater, deeper insights from what you're learning. Next question. If any. Ah, so Kazim, in your learning plan, just be careful. Oh, you know what, Hugo, you might have been trying to talk, but you were on mute. In your learning plan, just be, by the way, there's some advice I give that I'm not good at myself, but um, just agree with make a contract with yourself. I'm going to study X amount of time per day on this area, and I'm going to do it for, I'd say you got to do it for at least 6 months, and just be happy for each little step. And it might be very hard for you to plan your learning in the beginning, but trust me, if you keep trying to get better at planning your learning and then learning, you will get very good at that over time to where it's addictive. I mean, I'm an addicted learner now. I love to dive in. I taught myself reinforced learning. Well, teach yourself. You've got all these great materials out there. So, but meaning I just dove in and started figuring out what was important about reinforced learning, why it's necessary, when you apply it. And I started learning it, and I had so much fun learning it. But it was hard. Reinforced learning messes with your brain. It's so different. But this stuff, it's hard. I'm not gonna lie to y'all. It's not easy. It's going to be easier for some than others, but just dive in and start learning and ask a lot of questions on Tech Chat. Our family wants to help you. we grow, we're not doing it just because we grow better when we help you, but we do grow better when we help you. And we want you to experience the joy of helping others too, in growing too. Hugo, what else?
Okay, so one last question. I think that's the last question I have here. But if you still want to, you could raise your hand if you want to speak into the mic, or you could still send me a private message. Or if you're confident enough, you're not worried about your question, whether it makes sense, you could just put it in the chat. Okay, so
and Hugo,
yes,
let me add real quick, Hugo. Guy is sick today, so he had to cancel class and he can't moderate our mentorship session today like we planned. But what this means is Hugo and I will hang back. We can't hang back past 9, or it's 18 after the hour now. We'll hang back as long as 50 minutes after the hour, but just keep asking questions. We just want to stay here and help everyone. Main thing is we want to, yes, some of you are going to be overwhelmed. That's unavoidable, and I'm sorry for that. But we can still step you through the rest of the time now, and then we can, like we said, field questions on the Slack tech in our Slack work groups tech chat channel, and some of your concerns probably could be answered by just going through these 2 notebooks again carefully on your own time. But yeah, Hugo and I will stay as long as we can. So keep asking questions. If you need to sign off, our feelings will not be hurt if you need to sign off.
Okay, so what is a day in the life of a data scientist like? Workflow, like I think there.
Let me use some statistics language to describe that. It's a huge distribution. There may be weeks of data cleansing. And then you go through some encoding of data, meaning it's categorical data. It's in text format. It's like poor, I'm just giving an example, poor, no, bad, poor, okay, good, excellent. Well, we can't use that in machine learning, so we do what we call ordinal encoding. We're going to make that, bad is 0, poor is 1, okay is 2, good is 3, excellent is 4. Okay, now I'm using simple examples. And then we go through, and now we're getting to scaling, and we realize, oh, I didn't find all my dirty data yet. So then we need the scaling efforts helped us see there was some other dirty data. And maybe it was, oh no, there's some fields that should be numbers, and some of them, it's a number, but it's in text format. So we got to convert those to integers or floats. Then we go along and we finally get clean data, and it's encoded, and then it's scaled. And then we realize, oh, I've got a lot of collinearity. I got to, again, it depends on where you're at in the pipeline. But in my last role with UL, I was creating this giant AI. I had to rely on principles. I was creating new tools all the time, but it was still, I was able to do that because of my command of concepts and my ability to learn new things fast. So it's just such a mixture. It's a hodgepodge. You might be learning something new. You might be reviewing something you haven't touched in a while. You might be doing some SQL queries, and then once you've got them working, you're embedding them in Python code to automate those queries and pull data in from some database and process it in Python. And then you might be troubleshooting code the next day. You might be creating a new specialized class. Another day, you might be pulled into a fire and you're using scikit-learn, and you're doing stuff very similar to what we did today. It just depends on your organization's needs, what you can do, what you can learn. It changes. It really can change from day to day and organization to organization. I rambled, sorry. Hugo, you're on mute. Hugo, I think it'd be safe for you to stay off mute. Hugo. Well, I don't know what happened to Hugo's mute control, but he may have had to step away too. I can see the chat, and Kazim, you're very welcome. Let's see. How to deal with, and I don't think I'll ever. Okay, I'm not going to say who said this because it was a direct message. How to deal with, man, I don't think I'll ever learn this. This is so hard. Feel dumb. Hey, I know where you're coming from. We've all been there. And I've started learning these thoughts, sometimes just keep down for a week or so. You cope with it by starting with really simple examples and asking for help. We're very safe people. We don't berate anyone for something they don't know because we've all been there. We're trying to help one another. So yeah, I would say go through these notebooks and start asking questions. And don't feel like you've got to understand it all right away to be able to use it, because the people at Scikit-Learn, they have tried to make it so anyone can use this stuff. But at the same time, over time, it's better to understand it deeper and deeper. But please, if like it could be as simple as, wow, what is a notebook? And what is Google Colab? And how do I start to use that? We can help you with that too. In fact, we even have some pre-recorded lectures that will help you get started with Google Colab. Now, Google Colab's a notebook system actually that you run through the internet. When we did this stuff today, we were using Google's servers to run this code. So you only need a internet access and a browser to do this. But if you want to run Python on your own system and set it up and use an integrated development environment, Hugo and I will share pre-recorded lectures for you so you can just watch those at your leisure and get going with Google Colab and Visual Studio Code. Okay, I'm gonna look at this. This is Lotta Feet, and I don't think she minds me going through this publicly. How do you create value to the company as a data scientist? My company is willing to help me progress into the role, but they want to see how it's valuable to them. Oh, this is great, Lotta Feet. It is it safe to say that data science is valuable? Yes, I think so. Because if an organization has data, you can create value from it. Oh, lots of feet. This question is just from heaven. Thank you.
Okay, Dad, I don't know if you can hear me.
I can hear you now, yes.
Okay, great. So my laptop just froze, but I think Attila has their hand raised. Maybe we
Oh
can.
yeah,
Yeah,
but let me
yes.
let me finish with Lotta Feet's question real quick. And sorry I didn't
All right
see
then.
you,
All right then.
Attila. We'll get to you right away. Let me go. Sorry, I wish it had these navigation buttons at the top of this. Let's see. There we go. Okay, so being a data scientist, Lotta Feet, I'd love for you to read this blog post because I literally wrote it for you along with Manpreet and Abdul. And then I think read this one too. Everyone should read this one. And then, of course, this personal data science learning plan. I send links to these 3 blog posts out to everyone that approaches me for mentoring because I wrote these for you. We're trying to finish up another important post on interviewing and creating resumes, but it's been long going because we want it to be very helpful. But you dive in and really, I would learn as much as you can from Hugo first about data storytelling. And then just keep learning and practicing basic machine learning. Now, I should point out, we started at the end. Why? I wanted to show you how to do the modeling, but then show you, well, what if the data is not clean and pre-scaled like we got? Yeah. Now we'll show what you got to do to get the data to that state that we did here today. And so that's going to take more lectures than this one we did today. Well, what I'm trying to say is the stuff we're going to teach in the next 2 or 3 sessions is probably more important than what we did today because there's some elements of data storytelling you can do that are super powerful from those. And so, but there's also another lecture that Hugo and I will share with you that Greg our brother Greg, or Uncle Greg, and I give as a presentation together called um, Business and Data Science Collaboration for Greater Returns on Data. Now, we could have just called it Increasing Your Return on Data, but it's a marriage presentation between business and data science. And so, Latifit, the short answer is make friends with your business leaders and your domain experts and find out what concerns them the most. Then look for the best intersections of what data is on hand to answer those concerns. But again, Hugo and I will share the link to that talk with y'all. In fact, maybe I can find it real quick. Hugo, am I supposed to take Attila's question next? Is that the plan?
Right, Dad, right.
Okay, let me get this link of mine and Greg's talk and put it in the chat.
Okay, Dad.
I've got it. And here it goes, guys. So Latifit, I would love it if you would, going back to everyone here. I'd like your feedback on this presentation too. Yeah, you're very welcome, Latifit. Latifat, excuse me. And so much more to say, but Latifat, let's keep this conversation between you and I and Hugo going on that tech chat channel so that we can answer these questions more in depth for you over time. This isn't a one-time answer. This is us helping you and learning through your experiences too. Okay, Attila, thanks for waiting.
Thank you very much. It's really a lot of useful stuff, and also for this fabulous masterclass. My question is,
just so you know, this is a basic class. Yeah, I can hear you.
Okay.
This is a basic class.
But still a lot of information and also very useful. So, my question is, if you have a specific problem, how do you know with which model or to start? Let's say you have some kind of business issue and you want to solve this. And are you starting with linear regression model, and then if not work, you go to bias, or you know exactly with which model you start? So this is my question.
So, yeah, good question. Please understand, we've only started with the in part of the entire process. Do you always need machine learning to give value to your business, to get a return on the data? No. That's why I keep emphasizing that you guys learn from Hugo how to use tools like Power BI, or basically, let's not make it tool specific. What we're trying to say is you want to inform your organizations with data. There's some things we do in the pipeline of processes, of methods, and the mechanisms we use in that pipeline. When we're moving toward machine learning predictive modeling, there's a lot of things we discover in that. There's a lot of stuff we do in that process that is very good data storytelling elements. So you don't always need a predictive model from machine learning to give great value from data to your organization. However, some of the insights you get before you get to predictive modeling actually require modeling algorithms to get that information. For example, when we let me go over to this notebook again. You notice how up here, you see when we got these weights? Well, what is this really telling us? Now remember, this assumed that we already had scaled data, but normally we are going to scale the data. And once we've scaled the data carefully and all the data is scaled in a similar way, sorry, oh gosh, I went right past it. That's because it didn't stay highlighted. These modeling weights, what are they doing? They're telling us this feature is the most important. This feature is the next most important. This feature is still the next most important, and this one's the least important. Guys, I find this knowledge more valuable for the organization than being able to make the predictions. Why? When you're looking at predictions, you have to react to those predictions. But when you understand the importance of each feature, that gives business insights so you know how to react so that the business knows how to react. So if they know that this feature is more important, that's a strength. They can try to improve the thing that's related to that feature. That's proactive instead of just reactive. So this is a data story right here. Now, we've just done pure math, but what would these features be actually in a real scenario? Hugo, you still there? We might
Yes,
have
I'm there.
lost Hugo. Okay, great. Okay, Attila, did we finish
I'm still
answering your
here.
question? Okay. Okay, good.
Yes.
Did we?
I mean,
Okay.
especially if you have a demand. I mean, if you want to predict the demand, right? So for your next sale. So
Yeah.
we did some analysis based on Excel, but I want to understand how you do it in machine learning. And
Yeah.
because there
Yeah.
are also a lot of components or let's say inputs where you need to consider. I mean, this kind of sales demand is dependent on, I don't know,
Right.
market.
Yeah. Right. I just want to emphasize, I'm not trying to say that learning how to do predictive modeling with data is not important. I'm trying to say, make sure you appreciate all the value you can get from the whole process and give back to the organization. While you're going through machine learning development, there's great insights you can give back to the organization along the way. For example, when you're having to clean the data, how did the data get dirty? Can we fix this at the source, the thing causing that dirty data? Get up out of your seat or get on a Zoom call and say, hey, we need to fix this dirty data. Well, why don't you've got a routine now, just automate it. That's not the point. That still costs time to run that cleaning. Let's as an organization make sure everyone understands you need to enter that as a number. A lot of times that's a process that's already automated. It just needs to be improved. You're looking, then you go down further and you realize, oh, when people enter in good, could we just go ahead and convert that to a 2? When they enter in bad, could we just convert that to a 0? If they misspell, can we tell them that's not a valid option? Stuff like that. We want to make sure the data's coming in clean, but until it gets cleaned at the source, we still have to clean it to model with it. All of that's important. Then on scaling the data, we may never get rid of that, but we could put automatic scaling in at the source. There's a lot of things we can do over time with the organization to make all this flow better. But it's a matter of constantly being diligent to see what advice, based on me going through this processing and exploration and visualization of the data, what advice can I give back to the organization? And look at what I'm highlighting again, what things that I'm learning about the data can I give back to the organization to help them? And do it frequently and informally. Don't feel like you always have to have some fancy presentation. Just give the information frequently and informally, like you're talking to your friends that you really care about. And you care about the business because it's y'all's income. But again, I'm asking y'all to learn from both me, the other members of our family, and then Hugo's very good data storytelling skills too. Okay, next question. Very good questions, by the way. And Attila, just to help the
I'm not
management.
seeing any other questions on my end. Well, I don't know if there is anyone who wants to raise their hands and ask a question, or you still want to type your question in the chat.
Attila, if you feel like we answered your question enough, go ahead and raise your hand to help Hugo's management of the questions. And I think I'll stop sharing now. I hope if y'all are having trouble getting copies of the notebook, we can make copies of them available through that Slack channel, the tech chat channel on our Slack work group. I'll stop sharing so I can see more faces. Well, listen, I know some of you may have questions and you're not sure how to phrase them yet. That's okay. Just stay engaged with us, get on our Slack work group, ask questions in tech chat. We will get you up and running. We can start with some, we can keep this going, by the way. We can go through some toy data sets on scikit-learn. We could go through some ongoing competitions on Kaggle. I don't want y'all to feel like this is a 3 and done thing. This is what Tech Time Chat was created for, to get into the depth of how we do this. And I'd love to see Hugo take some sessions for this time for Power BI and someone else for Tableau, which is a competitor tool to Power BI, and maybe Google Data Studio. Our family is more about helping people give insights to the world with data, not just, this is, let's not, we want to move beyond just the normal classroom. This is mentoring. This is mentoring at depth. And your questions, I assure you, when you're brave enough to ask a question, it's helping everyone else. Okay, anyone else? Hugo, are you getting any private questions?
I don't have any private questions anymore. So apart from whether the recording will be made available, yeah, surely the recording will be made available.
Let me ask one question in that sense. So now that we are mixed, some of us are very beginners and some of us are advanced learners. So what's the minimum expectation of you, the teachers and the organizers of this mentorship after this class? So what do you think our minimum qualification in this knowledge should be? So that, I don't know if that's sensible for me to ask anyway.
Oh, no, all these questions have been great, including yours, Aziz. Let me see if I'm understanding your question correctly, though. I think you're basically asking, where do we go from here? Is that right?
I guess, yes.
Okay. Keep coming, keep asking these great questions, but try to go back through these notebooks. Really make sure you got copies of them and you know how to run them. But guys, please, can't encourage you enough. Don't be afraid to ask any question. Even, I don't even know how to get started with CoLab. We'll help you with that. We'll share a video lecture, and if your questions don't get answered through the video lecture, we'll answer it in upcoming sessions. And I don't think Hugo and I are afraid to change the schedule to get you new people up and running in a comfortable way. Right, Hugo?
Absolutely correct, that absolutely.
Now, there's a welcome message I give to everyone that starts in our Slack work group. I'm putting it in the chat right now. It's a long, oh, it might have gotten cut off. Yeah, if you send me a link, send me a question on LinkedIn, like just say, hey, give me that intro message you give to everyone that joins the integrated family. Just send me a LinkedIn message, say, I want that message, and I'll copy and paste it in there for you. Okay, Aziz, a few months ago, I couldn't even pass data set path on Jupyter. I know your pain. And by the way, there are times when I'll spend 30 minutes just figuring out how to load data from some new source. It happens to all of us. So when you're struggling with the basics and you're new, don't feel like you're the only one that ever had a struggle. Just because you saw a list of steps on a blog post or a website of how to do something and then it didn't work for you, don't think you're the only one that's ever encountered that. This is technology. It can be hard, but we're here to help you. We understand. Again, we run the most expensive mentoring on the planet because we're asking you to commit to pay it forward to help someone else through their learning pain. So it's ease, we understand. Latifat, did you want to ask a question? I see you on camera now.
I don't know if you mind me speaking through the mic. Is that okay?
Not a, oh, absolutely.
Yeah, like I'm very interested, and it's so unconventional because you're wanting people to pay forward rather than actually have monetary value to it. I previously did a data science course prior to joining this, and I paid a lot of money, but I still don't know anything. And
we know your pain.
Yeah,
we understand.
It's very frustrating, to be honest with you, because I know about linear regression and a couple other things, but still, it's just like this is the first time that I really got the in-depth of how the role works. You know, how you can actually progress further.
It's a blessing to hear you share this, by the way. Thank you.
Like, I just wanted to show my face because I wanted you to see that there's a real person behind this. I
yeah.
And I'm just wearing a t-shirt, but still.
Thank you for coming on camera.
I'm sincerely grateful, and like I'm so inspired that I even feel like joining your team, you know, like becoming so good enough that I can actually do this as well.
You're missing the point, Latifat. You don't have to be good enough to join our family. You have to be human and care about other people. Those are the only two, like I'm not allowing Caleb and Ambrose, which are my two favorite dogs of my 5 dogs. Well, sorry. I think I just hurt Ivy's feelings. It's just, I haven't had her as long. Sorry, I'm joking. Yeah, they can't be members of Integrated because they're dogs. You have to be human and you have to care about other people. Well, I guess there's a third one, right? You have to love helping the world with data. So Latifat, I'm saying your name wrong, Latifat.
It's okay.
We have a longer term vision, but for the integrated family, but it's still forming. So join us, grow with us, but be patient. We're actually hoping to become a family business, but not right away.
No, but it's amazing. I like the cause, and it's really inspiring me right now. So I will
awesome.
Take on those courses. I put in the link and I put in everything I could in the Slack channel, and I will work my way through. And I'm very inspired. I'm not gonna lie. I'm very inspired.
So Latifat, I want you to know what inspires me to do this. Now I'm going to use one name, but I could have used well, I'll use it more than one name. I'm going to give you my inspiration. Manpreet, Hugo, Gus, Valerie. I could go on and on. I have people all over the world that call me dad, not because I asked them to. I'm going to try not to cry right now. Latifat, you are very welcome to join us. Why? Because you are brilliance in the making. I'm not messing with you here. I'm not trying to make money here, but I am trying to build something amazing. And someday, Hugo and Gus and Valerie will make me look like a bad mentor because they will be so much better than I am now, but it'll be because of what we started here. And Integrated isn't magical because of me. It's magical because we have a more together spirit. So stay with us and help us be better, Latifat. We need you because we're losing we're losing the perspective of a new person to this. We need you to help us know how to make it more explainable. When you start to come out of the confusion zone, say, oh, you know what did it for me is when you said that. And then we know to emphasize that. Or if you had said this, it would have helped me. That doesn't mean it would help everyone, but now we have another tool to help the new people.
Yeah.
And that will be magical for us.
I will explain everything. I hope I don't become annoying over time.
No, no one's annoying. And then you join us, you start learning, but just give back as soon as you can. And we'll help you know how to give back too. Something bigger will come of all this, but we're not worried about making money right now, especially not off the people that need help. We're hoping together as we get more together better. I love to use bad grammar, especially when it's more descriptive. We're going to get more together better. Okay. What we want to do is we'll find a way to monetize ourselves, but not in a way that we charge the new people, in a way that the world's wanting to pay us for what we can give them. But we're being patient with ourselves right now, gentle with ourselves about how we're going to go about that.
Yeah. It's truly amazing. I don't know. I even did a course with Oxford University on data analytics and data design, but it didn't click like this course, like this. I don't know how to explain it, but we put it in layman terms that made it so easy for me to just understand how my future would look like. A lot of the we go into things thinking, because monetarily wise, it's gonna make our life better. We're gonna help our family. Yes, that's one aspect of it, but I also want something to be passionate about. And I find myself consistently being drawn to data and solution solving. I really like finding out the solution and what is, if a person asks a question or even are telling me a problem, the first thing I think is, how do we solve this? I think it's just an optimism thing. You just always look for a way out. And I can sense that from this course, and I can sense it from the way you've spoken, and I can attest from people like us. I can see a lot of people are praising you so much, and it just sounds so good to be true. It was my first time even going for anything like this, and I just want to thank you. I don't know. I'm blabber.
Oh, it's okay. No, it's a blessing when people let go like that, and I'm constantly overwhelmed by the love of this family for me and for each other. There's people that are just amazingly helping others already. To me, and Gus and I've had some private talks about this. We are blown away constantly by how much Hugo's already giving back. It's truly amazing. But Latifat, we need you to help us get still better. So you are, and in a way, Latifat, you are the expert right now. You can tell us better than anyone because you're brave and you're willing to come on camera and share this level of stuff. You can help us better than anyone right now know how to get better. We need people like you that are new to be brave and say, I am confused here, help me here. I am confused here, help me here. Now, how do I put this together? We want to get better at that. The burden's on us, but hey, the burden's on all of you to say, this is what I'm not getting. So we'll keep going. This is what we were hoping Tech Time Chat would become too. Something more focused. In the mentoring sessions, those are beautiful. They're more like life skills to be a good data scientist. But we needed to get this Tech Time Chat launched, and you are the brave person helping us make it better. Aziz and, oh shoot, my names are escaping me here. Oh, I think he had to drop off. But many of you were brave to ask questions and confess, I'm lost. We get that. We understand. It's just, and that original material that you felt like you weren't helped much by, hang on to it, go back to it. You might find, oh, now that the integrated family helped me, this stuff is really valuable. I just needed more background to make value from that. It probably is good stuff. I got to tell you a funny story. I bought these expensive at the time engineering textbooks. And I'd read them and I go, oh. And then I'd read them again at the end of the semester and go, oh, it makes more sense now. I'd read them years later. I mean, I'd really like 40-year-old textbooks, a lot of fun. And I read them like, this is a piece of art. This is worded so well. But it took me a while to appreciate those books because I had to learn enough to, it's hard when you're new. It's just hard. Okay, I want to give everyone a bio break time. I hope everyone that was here can join us for the mentoring session. I want, in case you've never been, it's like coming into our family's living room, which we hope we have a physical one someday. But right now, it's just a virtual one. So we'll see you over there. I think, let's see. I want y'all to just leave graciously, and I'm going to look at the chat. So if you left something in the chat, I'm just going to look at it, but y'all leave at your leisure and take a break before mentoring if you plan to come to mentoring. Aziz, I was never angry at you, by the way. I hope you know that. I think I understood your message, but I'm not sure. And thank you. You're a blessing, Aziz.
I
Can I say something to, sorry,
Oh,
can I say something to
Ngozi.
Aziz?
When Ngozi speaks, we all shut up and listen. Go, Ngozi.
Aziz, welcome to the family. Yeah, it's just some people make it difficult for new people to learn. Some people make it a lot easier. I think you've come to the right place, and you can get more support than you can get from here. That's all I wanted to say. You already know it, but hang in and hang on. That's all.
All right, so I think this is where we draw the curtain for today. I want to thank every one of you for showing up. We still have another session coming up in the next 5 minutes. That's the mentoring session that talked about. And it will be great to have you show up for that. If you're not on the Slack, I would send an invite link to all of you via email if you want to join the Slack channel. So if you want to join, just respond to the email and you'll be added to the Slack. And so thank you for showing up. We appreciate you. We are here because of you. And it was because you showed up that we had an amazing, we planned to do 1 hour, but here we are 2 hours. And it seems like we don't even want to stop or slow down. And thank you. Thank you, everyone.
I'm just hanging back in case there was a question in the chat that I missed. So I'll hang back just a little longer. If you want to come off mute and ask, that's fine. But I'll just make sure that Hugo and Gus and I are the last ones to hang up.
Right. Okay, so thank you. The link to the recording we sent to everyone is actually live streaming on YouTube right now, but I would get the link available to everyone. So thank you, everyone. And officially, bye-bye. We'll see you in mentoring.